Yes, good morning, students. Good morning to everyone. Okay, uh, today we are going to start the valued course on programming microcontrollers using embedded C. Okay, this valued course will provide you a knowledge how to program a microcontroller using embedded C. Okay, in your fourth semester, okay, you have learned microprocessor and microcontroller. Yes. Which kind of language we have used to program the microcontrollers? Kindly respond in chat. Yes. Which kind of programming language? Yes, very good, Shivakumar. It's assembly language program. Okay. Here we are going to, in this value-added course, we are going to do the programming using embedded C. Okay, we are going to program the microcontroller using embedded C. Okay. This is the short-term course, okay, through which you can able to learn the following things. Yes, the course objective is to study the operation and interfacing of I/O devices with microcontroller. Okay, how the I/O device are working and how to interface the I/O device with the microcontroller. Okay, so that is the objective, first objective of the course. Okay, the second objective of the course is to study the embedded C programming concept. Okay, program the microcontrollers and the I/O devices available in the microcontroller. Okay, I hope you people can understand what is meant by I/O devices. Okay, so I/O devices means the devices which are connected to the system, which is going to provide some input. Okay, so the system is going to process it and it is going to produce an output. Fine. So such we call it as I/O devices. I mean the device which are giving input and the device which are showing the output or displaying the output. Okay, that we call it as I/O devices. Okay, to process the input and output, obviously we need microcontroller. Okay, so here we are going to study the embedded C programming concept to program the microcontrollers and the I/O devices interface with it. Okay, fine. So you people able to develop and analyze real-time microcontroller based application. Okay, so that is the third objective of this particular course. Okay, so after this particular course you can able to program microcontrollers. Okay, so that you can design your own system, own embedded system. Okay, also we are going to provide an overview to Android app development. Okay, so using that Android app development, we can able to control the embedded system. Okay, through some wireless communication. Okay, so these are the objective we are having in the course. After you have learned the course, what are the outcomes you will get is, so you will be able to understand and explain the working of various I/O devices. Whichever embedded system you are looking, you can able to say the working of all the I/O devices connected to the embedded system. Okay, then you can able to program the microcontrollers. You can able to apply the embedded C programming concept, and you can able to program the microcontrollers. Fine. So as I told in the course objective, after you have learned the course, you can able to develop, design, develop, and analyze microcontroller based real-time application. Okay. To program the microcontrollers, we are having a variety of modern tools. Okay. Here we are going to use one among the modern engineering. Okay. Then you will be able to design and develop basic Android app to monitor and control embedded application for which you are designing the app. Okay. So with this particular course, you can able to have these outcomes. Okay, these are the outcomes of the particular course. Once you have completed the course, you can able to do these things. Okay, so these are the course outcomes. Okay, before getting into any course, you should ask why I have to study this course, why I have to learn this course, what are all the benefits I will get. Okay, so that's clear by this point, course outcome. Okay, fine. we are not going to cover the microcontroller concepts and all here, okay, because you people study. Yes, okay. So here we need a basic operation of a microcontroller. Okay, how a microcontroller is working, or what about its architecture, and what are all the I/O components present in the microcontroller, that you people have to know. Okay, so that it is easy to understand this value-added course. Okay, so basic operation of a microcontroller you must have. Then basic C programming concept you should have. Okay, but as a part C, we are having an overview to embedded C concept also. Okay, so basic C programming concept, if you are having, it's adequate for learning this course. Okay, I hope you people come across these two terms. Okay, microcontroller and C programming. Okay, so that's enough to learn this course. These are the prerequisite knowledge for learning this course. Then regarding software requirement, we are going to use MCU 8051 IDE. Okay, so which is an integrated development environment. So using that only we are going to develop the embedded C code. Okay, mere that software is not enough to do embedded C programming. So for that we need a compiler. Okay, so we are using SDCC compiler. Okay, I hope some of you people have done Arduino programming. Okay, so in that Arduino IDE you have the provision to type the source code. You can able to compile it, you can able to burn it to the microcontroller. Okay, here we are having SDCC compiler, which is going to support the MCU 8051 IDE software. Okay, without SDCC compiler installed in your computer, mere MCU 8051 IDE you cannot able to compile embedded C programs. Okay, so SDCC compiler we have to install. Fine. Then regarding the Android app development, we are going to use MIT App Inventor, which is an online platform to develop Android app. Okay, so all the software here we have mentioned are open source. Okay, that's going to be very, very important. You peoples are free to learn. Okay, that's why we are preferring the open source. It is available to everyone. Fine. So that's all about the software requirement. So we will go with the syllabus overview. Okay. So in module 1, yes, Sajid sir. Okay. Okay, Sajid sir. Okay. Yes, I have accepted. Okay. Okay, thank you, Sajid sir. Fine. So in module 1, we are going to have an overview to embedded C programming. Okay, as you people already know about these things, data types, variables, operators, loops, arrays, pointer, functions. So how this is handled in embedded C. Okay, so the same syntax here we are going to use. Okay, but it is going to have some differences. Okay, let's see what are the differences when we are getting into the course. Okay, then we are going to see how to interface and programming the IO devices. See, here we are restricting the IO devices. Okay, because the MCU 8051 IDE supports some of the IO devices for simulation purpose. Okay, so we are restricting the IO devices. It doesn't mean you can able to use, you can able to program only this IO devices after learning this course. Okay, it doesn't mean like that. Once if you people able to program the ports using embedded C, you can interface any kind of input output device, but you should have the prior knowledge of the particular device. Okay, so that's it. So here we are going to concentrate push button switch, LED, then 8 input switches and 8 output LEDs and 7 segment display. So in module 1 we are going to program some simple devices. Okay, is it clear to everyone? So module 1 la nama paak poradhu enna embedded C programming concept. Okay, we are going to explore what is embedded C, introduction to embedded C we will have. Okay, then the basic operation of LED switch, the 8 input and output devices, then 7 segment display we are going to have. Okay, so that's all about the module 1. Coming to the module 2, so here we are going to program the I/O of microcontrollers. So the I/O of microcontroller means what are all the internal I/O component present in a microcontroller. Okay, for example, in 8051 you have studied port, timer, serial UART, interrupt are there. Fine. So here we are going to discuss. Here we are going to have a demonstration how to write embedded C program to program the port, timer, serial UART, and interrupt. Okay, obviously in first module itself we may be start to program the ports. Okay, but timer serial UART we will be getting into the module 2 only. Okay, fine. Then we are going to introduce a concept inline assembly. Okay, so it's going to be a very important thing when you people are developing an embedded application. Okay, sometime you may need an assembly code can be inserted in between your embedded C programming. Okay, so at that point of time, this inline assembly coding concept can be used. Okay, so it might reduce the hardware requirement, memory requirement. Okay, it may reduce the memory requirement for your program. Some of the operation you cannot write in embedded C. Okay, so which are unique to a microcontroller. Okay, so that can be only done by the assembly code. Okay, so at that point of time you can insert the assembly code in between your embedded C program. Okay, so that we call inline assembly coding. Okay, then here in this module we are going to interface and program 4x4 matrix keypad, 4-digit multiplex 7-segment display, 8x8 dot matrix LED display, and 16x2 LCD display. Okay, so these are the things we are going to program using embedded C in module 2. Okay, I hope we people already came across the matrix keypad concept and multiplex 7-segment. The other things we have to learn, right? But here in this module, we are going to have all the working of all these I/O devices and its programming. Okay, coming to module 3. Okay, coming to module 3, we are going to configure and interface a Bluetooth module with a microcontroller. Okay, unfortunately, we don't have the hardware modules with us. Okay, regarding the previous things, but fortunately, I am having this particular module with me. Okay, so we can have a hardware demonstration when we are going to module 3. Okay, up to module 2, we'll be going to have only simulation. Okay, after module 2, that means in module 3, we'll be going to have some real-time demonstrations. Okay, so HC05 is one type of Bluetooth module. We are having variety of Bluetooth modules. Among that, we are going to use HC05. Okay, how to configure that Bluetooth module and how to interface to a microcontroller. So that we are going to learn in module 3. Okay, then MIT app inverter. So basic things about the MIT app inverter, and we are going to build an Android app to monitor and control a simple embedded system. Okay. So these are all the syllabus overview about this value-added course. Okay, am I audible? Can you people reply in chat? Yes. Okay. Is the course content is clear? See, as we are planning it for a short period, we are restricting to this I/O devices. Okay, fine. Okay, fine. So now we will get into the syllabus. So introduction to embedded C. So these are the things we have to answer so that we can understand what is meant by embedded C, okay, and how it differs from C programming, and what are the merits of embedded C over assembly language, and what are the limitations we are having in embedded C. Okay, the very first question we may answer. Okay, can you people have any idea about embedded C? Have you heard about the word embedded C? Okay, similar to this, already you have learned one programming language called C program. Am I right? Am I right? Kindly respond. Yes? Yes. Okay, okay, fine. Fine. Okay. So here the embedded C is a programming language. It is similar to your C program, but it is used to program microcontrollers available in an embedded system. Okay, if you take any embedded system, most of the time. Okay, it is as embedded C is popular. Okay, and it is easy to program. Most of the embedded system development have its own embedded C code. Okay, that means what I'm coming to say is embedded C is the most common language used to program the microcontroller available in an embedded system. Okay, but nowadays we are having many other languages coming into the picture. Okay, Python we can use. Okay, then Lua code, many things are there. Okay, many languages comes into the picture nowadays. Okay, fine. So it follows the same syntax of the C program. Okay, referred to be the most popular language to program the microcontroller for a long period. Okay, over a long period, this embedded C language is used to program the microcontrollers. Okay, fine. How it is going to be differ from C programming? Embedded C is fully hardware dependent. That means if you are if you are compiling any program and running any program using ANSI C, that means C programming, okay, it uses the desktop environment, the PC on which you are running. Okay, so that particular C programming is going to use the resources available in the computer itself. Okay, but this embedded C program is meant for a specific microcontroller. If you write an embedded C program to program a particular microcontroller, okay, that can be used only for that thing. That means it is fully hardware dependent. Yes, when you are writing the embedded C, you must know what are all the hardware present in the particular microcontroller. Yes, Hamdan said will be having void setup and void loop. Okay, fine. In the case of Arduino, it is like that, but the general syntax of embedded C is the same as Hamdan said. Okay, but the thing is, we have to initialize few things that we call it as setup, and few things it has to be run repeatedly. Okay, so this embedded C are used for building an embedded system. Okay, obviously embedded system means it is incorporating a microcontroller as a computer and running a program to do a specific operation. That means for a washing machine or a remote control or a induction stove. Okay, so many digital things we are having day-to-day life using an embedded system. Okay, so it is going to perform a specific operation, right? That means the embedded C you are writing for a particular microcontroller is only shoot for that only. It won't be suited for any microcontrollers. Okay, that's a very important difference. Whereas it is universal. The machine you are running, okay, is going to use the resource from the machine itself. Okay, fine. So it uses the limited resource of the microcontroller available in an embedded system, such as RAM, ROM, and I/O devices. Okay, some of the microcontroller have some other RAM and ROM configuration. Okay, if you are writing a program to program the particular microcontroller, it may not shoot for the other microcontroller which is not having the same capacity of ROM and RAM. Okay, so it's very, very important which microcontroller we are programming. That means it is hardware specific. Okay, hardware dependent. Fine. So here, in the case of C programming, we don't have any knowledge about the print operation or scan operation. That means scanning a keyboard value from the computer or printing some value in the monitor. Okay, do you know the hardware operations to program the C program, to write the C program? Printf, scanf நம்ம யூஸ் பண்றோம் இல்லைங்களா? Fine. We are ready-madely available with printf and scanf function in C. Correct? Whether you have any knowledge about the devices, keyboard எப்படி work ஆகுது, அது எப்படி read பண்றோம், display எப்படி display பண்றோம், whether you people have a knowledge about that when you are writing a C program? Yes or no? நீங்க C program எழுதுறப்ப என்னோட keyboard, yes, very good, no, definitely no. But here coming to the embedded C, you must know, that means the user must know about the hardware knowledge, okay, for which microcontroller they are using in a embedded system. Okay, so in the microcontroller na code eludurano, so on the microcontroller hardware knowledge we must find. What are the advantages of embedded C over assembly language? Okay, so assembly language nammale sollidalam enna advantage embedded C porappa, any idea you people having? When teaching the assembly language program itself, we have told. Yes, any idea? Yes, you have to know the instruction set of a microcontroller. Okay, if you want to program a particular microcontroller using assembly language, you have to know the entire, yes, you have to know the entire instruction set and its operation. Okay, so here coming to embedded C, it is easy to write code in embedded C. Okay, because it is a high level language, it is having some syntax to be commonly followed. Okay, if you know that, you can able to easily write an embedded C code for a microcontroller. Okay, so easily user can adapt to write program for different microcontroller. Okay, because here we no need to know about the instructions and all. Fine. So no need to know about the complete instruction set of a microcontroller, but still you need to know about few instructions, okay, whose operation cannot be incorporated in embedded C. Okay, some of the functionality, okay, cannot be incorporated in your embedded C program. So at that point of time, you have to use the assembly code in between the embedded C program. Okay, so for that, which concept we are going to use? To introduce assembly code in between embedded C, which concept we are going to use? The beginning, when we are discussing about the syllabus, I have told you. Yes, yes, very good. Inline assembly concept. Okay, inline assembly concept we are going to use. Very good. Okay, then embedded C program போறதோட another advantage என்ன அப்படினு பார்த்தோம்னா modification and updation of program is simple. Okay, if you want to update any new function, easily you can add it. Okay, but regarding the assembly language program, if you are writing some 1000 lines of programming, you have to search, okay, which register we have used for the particular function. Okay, if I modify that particular function, how it is going to affect the other things. Okay, so that things and all taken care in assembly. Okay, coming to embedded C, the modification or updation of program is going to be very, very simple. Okay, fine. Then using library files, ready-made library files, we can program any microcontroller easily. Okay, even without knowing the hardware, you can able to program, okay, using the library files. Okay, so these are the advantages of embedded C over assembly language program. Okay, then as everything is having its own advantage, it is going to have its own limitation. Yes, so coming to the limitation, what are the limitation we are having in embedded C means lack of performance in code execution speed. Okay, because the code optimization is depend upon the compiler. Okay, the compiler what you are using, it is going to decide the code optimization. What is mean by code optimization? I can do an operation in different way. Okay, say for example, if I want to generate a loop for 10 times. If I want to execute a loop for 10 times, I can use a variable, 8-bit variable. Okay, yes, I can use a 8-bit variable for holding the count value. In the meanwhile, some other compiler, it may initialize a 16-bit variable for the same count value. That means what? It is going to occupy, I mean, it is using the additional resources. I mean, it is using extra resources. See, எனக்கு ஒரு ரெஜிஸ்டர் தேவைப்படுற இடத்துல ரெண்டு ரெஜிஸ்டர் அதை யூஸ் பண்ணிக்கலாம் 16-bit வேரியபிளா அசைன் பண்றதுக்கு. Fine, that portion. When you are writing some function in C, okay, the compiler is going to decide which kind of assembly code equivalent to that will be incorporated for the particular function. நம்ம எழுதுற embedded C க்கு ஈக்குவலன்ட்டான assembly code அங்க ஜெனரேட் ஆகும். So So that is going to be converted into X file and it is going to be burned into the microcontroller. That means when this part, the source code, is converted into an assembly code, this problem comes. Okay, so it's depend upon the compiler. Some of the compiler may have a good optimization. Okay, some of the compiler may have some poor optimization, code optimization. Okay, if you are writing more line of code for the same program, which can be done in a simple lines, okay, so the execution speed will get automatically reduced. It doesn't mean the speed of execution going to reduce. Okay, code execution, that means if you are writing a program in assembly language, it takes some time. If the same function, if you are writing in embedded C, it takes some more time. Okay, so that's the difference I want to tell here. Okay, similarly, it is going to have another limitation. Embedded C, it is going to occupy larger space relatively than assembly language. Okay, so it is going to create memory constraint. When your application is having a memory constraint, that means you have to write a code within this space. At that time, embedded C may not able to support for that system. Okay, so for that we can overcome with inline assembly codes. Okay, inline assembly codes will improve the speed of the code execution as well as memory space. Okay, efficiency of the system little degraded when you are going for embedded C, but it is not much. Okay, relative to assembly language program, the performance will be little slower. Okay, so these are the points I want to tell about the embedded system. I hope now you people aware what is embedded system. Okay, how it differs from normal C program. Okay, what are the advantage of going to embedded C and what are the limitation we are having in embedded C? Yes, is it clear to everyone? Have you got the idea about embedded C now? Yes, okay, fine. So in this course, we are going to use SDCC, a software called SDCC. So it is the abbreviation is Small Device Cross Compiler. Okay, so it is the cross compiler. Okay, we are going to use to write embedded C program and compiling. Okay, what is meant by cross compiler? Okay, if you are writing a program, okay, which is compiling and running in the same environment. Say for example, C program you develop the execution of the C program happens in the same desktop environment. Fine. Whereas in the case of embedded C program, the program what you are writing, okay, it is done in the desktop environment, but it should be compiled and it should be shoot for the microcontroller operation. Okay, so here cross compiler comes into the picture. Okay, so generally to program microcontroller we need compilers. Okay, so here we are using SDCC compiler. Okay, then to understand the embedded C programming, we program the microcontroller AT89S52. Okay, why we are choosing this particular microcontroller means already you people have some awareness about AT89S52, so it is easy for you people to understand the programming concept. Okay. So the hardware specification of AT89S52, as I told, when you are programming a microcontroller using embedded C, you must know about the hardware specification and the registers. Okay, the special function registers involved in the programming of the device. Okay, so it's a 8-bit CPU code. Okay, it uses modified hardware to substitute for control-oriented application. It is having a Boolean processor. Okay. Then it is having 8 KB on chip ROM and 256 byte of on chip. Coming to 8051, what you have learned in the theory, 8051 படிச்சதுல what is the size of ROM and RAM? Yes. What is the size of ROM and RAM in Intel EV microcontroller? Yeah, 4 KB of ROM and RAM location. Dixon, thank you. Why I am getting to this particular hardware specification or features means then only you can choose a suitable microcontroller for your application. Okay, for example, if you go with any devices, we incorporate embedded system. Okay, 8051 will not follow this. It doesn't mean you cannot use 8051 use பண்ணக்கூடாது கிடையாது. Yes, my voice is breaking. Is it clear now? Yes, can you people able to hear me now? Can anyone unmute and say?
Clear diagram, sir.
Yes, okay. Thank you, Muntar. I think due to some network issue, I have disconnected for a moment. Okay. Can any people see?
Wait for a few minutes, students. We will wait for a few minutes.
Moon sir, am I audible now?
Yes, sir. I'm sir. Audible, sir.
Okay, Moon sir. Sorry for the interruption, students. Due to some network issue, I have disconnected from the meet. Is the presentation is visible to everyone?
Visible, Ram, sir.
Yes, okay, fine. Thank you. Okay, as I told earlier, we have to know the basic hardware specification of any microcontroller before programming. Okay, if you want to interface any, if you want to interface any analog devices, okay, at that point of time, you have to check whether your microcontroller is having an on-chip ADC. Okay, if your microcontroller is having on-chip ADC, then you can prefer that microcontroller rather than the microcontroller which is not having the on-chip ADC, so that you can avoid the external hardware interface. Okay, otherwise what you have to do is you have to connect an external hardware. Okay, then only we can able to read the analog value from the devices. Okay, fine. So here we are discussing about the hardware specification of AT89S52 microcontroller. Okay, so here we are having 8 KB on-chip ROM and 256 byte of on-chip RAM. Okay, then so it is having 4 8-bit general purpose I/O port. So we are having 4 I/O ports, each are having 8-bit. Fine. So 3 timer bar counter. Yes, 3 16-bit timer bar counter. Then full duplex serial UART port we are having. Interrupt control. Okay, we are having an interrupt control unit which can handle up to 6 interrupt. Okay, 2 external interrupt and 4 internal interrupts. Okay, in the case of 8051 microcontroller, you have 2 16-bit timer bar counter. Here we are having 3. So we are having one more timer overflow interrupt. Okay, fine. Then 2 power saving modes of operation available. So it is having watchdog timer. Okay, so with that we can able to detect. So this one is new to everyone, I think so. Yes, have you heard about watchdog timer? So this is an independent timer. Okay, this is an independent timer in a microcontroller. Okay, which has to be periodically initialized. Periodically we have to initialize. That means we will put some count value into this timer. Okay, before the count will get exhaust, we have to put a count value again. If that particular count value gets exhaust, that means it gets overflow or underflow, it will generate an interrupt. So your entire hardware will be reset. That means your microcontroller will be reset automatically. Okay, so that indicates what? There may be some abnormal program execution happen in your system. Okay, due to some disturbances. Okay, sometimes, rarely it may happen in a system. Okay, if any abnormal program execution happen means this watchdog timer will reset the microcontroller. Okay, is the concept is clear? See, that's why the name watchdog. Okay, it is continuously going to execute. It is going to count the time. Okay, once the count get exhaust, that means what? You have not feeded the food for a dog. That's the meaning here. Okay, watchdog means that's the thing intended in the name. Okay, you have to initialize the count periodically. Periodically, நீங்க வந்து என்ன பண்ணணும்? Count வந்து கொடுத்துக்கிட்டே இருக்கணும் watchdog timer. Okay, and the periodic timing அது போகல அப்படின்னா என்ன ஆகும்? The count value will get reset. கரெக்டா? ஒன்னு நான் count value 1000 போடுறேன்னா, so before it considering watchdog timer is going to be a down counter. 1000 count போட்டனா 999 998. It goes up to 1. Okay, once it reaches 0 and beyond that it cannot able to decrement the count. That means what? The user didn't initialize that particular watchdog timer in the program. That's the meaning for that. Okay, it doesn't mean you don't return a program to initialize the watchdog timer. Okay, sometimes due to abnormal execution of program execution flow change ஆயிடும். So watchdog timer may not able to get initialized. Okay, at that point of time, this watchdog timer is the microcontroller operation. So, நம்ம power பண்றப்ப reset ஆகும் சொன்னோம் இல்லைங்களா? Similar effect will happen. Okay, fine. Next, it is having on-chip SPI hardware. Okay, serial peripheral interface hardware. So it is a kind of protocol like UART. Okay, so it is available in this particular microcontroller, which is not available in 8051. Okay. Then it supports in-system programming. Okay, it supports in-system programming. That means if you are developing an embedded system and your microcontroller is placed on the embedded system, to program the microcontroller, you no need to remove it. Okay, so along with the system, okay, you can able to program the microcontroller just by disconnecting the hardware using jumper setting. Okay, perfect. That's all about the features of 8089S52 microcontroller. Okay, coming to the SDCC. Okay, every compiler has its own type of variables and data types. Okay, coming to SDCC, having these are all the data types. Okay, double underscore bit, char, int, long int, long int. Okay, these are the different data types we are having. Okay, Double underscore bit means it is going to use a particular bit addressable RAM location. Yes, we are having a bit addressable RAM area. From that, it is going to use one bit. Okay, whose the variable is going to map to the particular bit location. Okay, so what about the value you can store in a bit? What about the value you can able to store in a bit? In a single bit, what are possible values we can store? Either 0 or 1. Okay, so here it is not having any sign, so it is having unsigned range only. Okay, then coming to char. Okay, coming to char, it is going to be 8-bit or 1 byte. Okay, in the case of signed char, okay, char data types வந்து பாத்தீங்கன்னா character variable இருக்கு, அதுல வந்து signed unsigned category இருக்கு. Signed க்கு basic value நம்ம யூஸ் பண்ணிக்கலாம். Okay, it's very important. If you are assigning a variable as character, you should not give the value beyond this range. நீங்க எழுத போற அந்த embedded C programல நீங்க கொடுக்கக்கூடிய அந்த நம்பர்ஸ் வந்து -128 to +127 decimal இந்த ரேஞ்சில தான் இருக்கும். Fine. Beyond that, நீங்க வேல்யூ கொடுத்தீங்க அப்படின்னா signed character பொறுத்த வரைக்கும் it will produce an error during compilation. Okay, yes. Instead of unsigned char data type, you can give a value from range 0 to 255. Okay. Yes. Is it clear? Is it clear? Yes. Okay. It's very important. Data type நம்ம கண்டிப்பா தெரிஞ்சிருக்கணும். ஏன்னா நம்ம வந்து அப்ளிகேஷன் சூஸ் பண்றப்ப வேரியபிள் இந்த பர்టిక్యులர் ரேஞ்சுக்குள்ள தான் இருக்கலாம் அப்படிங்கறத டிசைட் பண்ணிட்டு based on that we have to choose the data types for a variable. Okay, coming to the integer, what about the size of the variable assigned for integer or the data type integer in C programming? Can anyone say? Integer அப்படின்னு சொன்னோம்னா அந்த C programmingல அதோட சைஸ் என்னன்னு தெரியுமா நமக்கு? Whether it is 8-bit or 16-bit or 32-bit or 64-bit. Any idea? 4-byte. It's not 4-bit, 4-byte. Correct? That means 32-bit. Here in the case of SDCC compiler, the data type int means it is a 16-bit variable. Whatever the variable you are assigning that to data type int, you can have a value starts from -32,768 to +32,717 decimal. Okay, so this is the range of the signed numbers you can use for signing. For unsigned, you can have a range from 0 to 65,535. Yes. Okay. Coming to the long, it is going to be 4-byte length or 32-bit. Okay. So it's a huge number you can use. Okay. When you are having a value greater than this range, okay, you can go for long int. Still, it is not sufficient. Okay, you can go for long int. Okay, it is going to be 64-bit. Okay, kindly think about the hardware of your microcontroller. It's a 8-bit microcontroller. That means when you say character, it's going to occupy one register space. That means 8-bit. If I am declaring a variable as int, it's going to use 2 memory space. Yes, as here each memory space is having 8-bit, it's going to have 2 registers. Okay, long int 4 registers. That means for when you are writing a embedded C program, okay, you have to carefully choose your data type for a particular application. If your particular function has an input range within 0 to 255, you can always use character variable. Okay, or else you can go for integer. Based upon the requirement range of the numbers you want to assign variable, you have to use the data type. Okay, so these are the common things you can know about the C programming. Okay, in some of the compiler, this double underscore bit. Okay, நீங்க ஒரு வேரியபிள் அசைன் பண்றப்ப டபுள் அண்டர்ஸ்கோர் பிட் நம்ம இந்த கம்பைலர்ல யூஸ் பண்ணோம். Instead of that, you can also use the data type bool, BOOL. I am typing in chat BOOL. Am I audible in the second class? Classroom 2? Students, am I audible in second class?
Audible, Ram, sir.
Okay, I think my presentation stopped.
Classroom 1 la presentation cut ஆயிடுச்சு, Ram, sir.
Okay, wait. I will just show. Students, wait a moment. Mukund sir, is the screen is visible in both classes now?
Visible, Ram, sir, visible.
Okay. Due to some network issue, I'm getting disconnected. Okay, fine. Coming to this bit variable, okay, that data type bit, okay, in some of the compiler, you can use the data types bool, BOOL, that stands for Boolean variable. Okay, when I say Boolean variable, it is going to be 8-bit only, but the value of the variable is going to be either 0 or 1. That means all 8 bits are 0 or simply 7 zeros followed by 1 1. Okay, are you able to understand the difference between bit and bool? Yes? Can you people understand? Sorry for the interruption, students. Okay, fine. Okay, then coming to double underscore. Here the dash stands for double underscore s bit. Here it stands for 1 bit only. So the value can be either 0 or 1. Then double underscore SFR. Okay, so it's going to be 8 bit minus 128 to plus 127 or 0 to 255. Okay, so these two data types, it is supported in embedded C. Okay, regarding the SDCC compiler. Okay, what it means double underscore S bit and double underscore SFR means you can assign your special function register bit. Say for example, for a particular port bit and our value assign பண்ணிக்கலாம். Say for example, the address of port 0.0 is 80H, correct? So it is a bit address. So I can assign a variable double underscore S bit P0 underscore 0, okay, at that particular address. Like that you can map. So using this two function, you can tell the hardware, I mean you can tell the compiler what are all the resources you are assigned for which letter. Okay, நல்ல ஒரு விஷயத்தை புரிஞ்சுக்கணும். நமக்கு அசம்பிளி லாங்குவேஜ் ப்ரோக்ராம் பொறுத்த வரைக்கும் மாற்ற முடியாது. போர்ட் 0 அப்படின்னா P0.0, போர்ட் 1னா port P0.0 na P0.0. That only we can use in the program. Okay, but here you can modify in the header file using this two function double underscore S bit and double underscore SFR. For example, accumulator register நம்ம ஏன் யூஸ் பண்ணுவோம்? எதுல assembly language programmer. Here, if you want, you can use it as ACC. Okay, that has to be defined in the register definition file. That means header file you are writing for your embedded C program. You are including for your embedded C program. For embedded C program, microcontroller, the very first step, we have to include the header file, which is going to have the register definition for the particular microcontroller. Enna register la irukka adoda address la enna naming will be mapped using this two data types. Okay, so this is the thing which is not available in the case of normal C program. Okay, so these are the slight variation we are having in embedded C from normal C program. Yes, okay, fine. Coming to the operator symbol, you people already know the same symbol we are having here: plus for addition, minus symbol for subtraction, then hashtag symbol for multiplication, slash for division, percentage symbol for modulo operation, then plus means increment by 1, minus means decrement by 1. Okay, so these are the operator symbol we are having. See, why I am saying this kind of thing, when we are writing an embedded C, we are using a compiler. Universally, all the compiler will use this operator symbol only, but there may be some slight variation, or there may be some extra symbols which can do some special operations. Okay, so that's why I'm mentioning the operator symbol and its operation. Okay, then coming to the symbols, ampersand, it means bitwise and operation. Okay, we are going to perform bitwise and operation. Either it is a single bit or 8 bit, it is going to perform a bitwise and operation. Fine. Then this symbol, a straight line, it is going to be used for OR operation. Then cap symbol we are going to use for XOR operation. Then exclamatory symbol, it is for NOT operation. Yes, this point I want to tell you. Okay, in some of the compiler for NOT operation, tilde symbol is used. Tilde symbol is used. I hope you people know what is meant by tilde symbol. Can anyone type in chat? Can anyone type in chat? Yes. Can anybody type in chat? I think in your mobile phone or your computer you will be having. Yes, the same symbol. Okay, in some of the compiler, this symbol is used for NOT operation. Okay, that means complement operation. But here it is used exclamatory symbol. Okay, exclamatory symbol if you are using in between the operand, that indicates it is to be a NOT operation. Obviously, for NOT operation, you will be having only one operand. So before the operand, you should use this particular operator. Okay, then less than symbol 2 times namakku irundhuchuna adu per left shift operation. The direction indicates we are doing left shift operation. Okay, then the next one indicates right shift operator symbol. Okay, the right shift operator symbol. Okay, which are equivalent to your rotate operation in your assembly program. Okay, then single equal to use pannona, we are going to assign a variable. Okay, assign a variable with a value. For example, a equal to 10, char a equal to 10. That means I am assigning a variable a, which is going to be a data type character variable. Okay, which can be given with a value 10. Yes, can I write a value like this? I will type in chat. Char a equal to 300. Is it valid? If not valid, tell me the reason. This thing is valid or invalid? Just type in chat. Not valid. Why? It's not valid. Why? What about the reason? Yes, in the case of unsigned char, we can have a range from 0 to 255. Okay. Again, if you are simply assigned int, okay, or char, okay, the compiler automatically will choose one of the data type, signed char or signed integer. Okay, you have to specify which type of character variable you are assigning, okay, to the particular thing. whether you are going to use a signed number or unsigned number. If you are going to use unsigned number, you have to write unsigned char. Okay, otherwise the compiler will automatically consider that as a signed char. Okay, so we have to specify signed or unsigned. Then shorthand operation. Okay, if you write a plus equal to b means that is equal to a equal to a plus b. That means you are adding some variable and with a variable and storing it to the same variable. Similarly, a minus equal to b means a equal to a minus b. Similarly, for multiplication, division, then a plus plus means a equal to a plus 1. Already I have told you plus plus means increment operation. Minus minus means decrement operation. Okay, so a equal to a minus 1. Similarly, a left shift n times. It can be written like this. That means the data available assigned to the variable a, it must be shifted to left hand side for 4 times, and it can be stored in the same variable. That's the meaning for this left hand things. Left hand side la namu kuduthirukkiradhu ellame use பண்ணக்கூடிய notations. Okay, shorthand operations. அதுக்கான மீனிங் வந்து இங்க ரைட் ஹேண்ட் சைடுல கொடுத்திருக்கோம். I hope all of these things you people know already. Okay, fine. Next, variables in C. Okay, again coming to the variables, where you are assigning the variables in your embedded C program. Based on that, it is of 2 types. One is global variable. Global variables must be declared outside the functions and the blocks of a program. அதாவது உங்க ப்ரோக்ராம்க்கு இடையிலயோ இல்ல ஃபங்க்ஷனுக்குள்ளேயோ நீங்க ஒரு வேரியபிளை டிக்ளேர் பண்ணீங்கன்னா அது என்னது? Local variable. Okay, what is the difference between local variable and global variable? This is a C concept. Already you people know about it. If I assign a global variable, what it means? Say for example, if I am assigning a global variable x equal to 10, that means what? Either in your main program or any function, the value x, it is going to be represent the same thing, same variable. Okay, in the case of local variable, okay, it is within a function. Within a function you can declare some variable. Okay, once you come out of the function, that variable cannot be valid for the main routine. Is it clear to everyone? Variable which are valid within a function are termed as local variable. If it is valid for the entire program, that we call it as global variable. Okay, fine. Regarding SDCC compiler, you cannot able to declare variable in between the functions. Okay, so whenever you are writing embedded C program using this particular compiler, variables must be declared at the beginning of the function. Say for example, for loop use பண்ண அப்படினா அதுல யூஸ் பண்ண வேரியபிள் முன்னாடியே டிக்ளேர் பண்ணிட்டு தான் அந்த for loopல யூஸ் பண்ணணும். Okay, in the case of Arduino programming, நீங்க போறப்ப என்ன பண்ணுவீங்க? For int a equal to 0, a less than 10, a plus plus னு யூஸ் பண்ணுவீங்க. கரெக்ட்டா? Yes or no? Unfortunately, this compiler, SDCC compiler, won't support such things. Okay, you have to initialize the variable what you are using in the function before using it. Okay, so beginning of the function la நம்ம என்ன பண்ணிடணும்? Variable declare பண்ணிட்டா the case of SDCC compiler. Okay, so that's all about the variables. Okay, then coming to the loop concept. So loop என்ன பர்பஸ்க்காக நம்ம யூஸ் பண்ணனும் தெரியும்? To do iterative operation. Okay, loop can be used. So loopல நிறைய for loop இருக்கு, while loop இருக்கு. Yes, additions இருக்கு. So அதெல்லாம் டீடைலா போவேனா இங்க ஒரு syntax மட்டும் பார்க்கலாம். So as I told, int it is I only, so capital I மாதிரி அது print ஆயிருக்கு. Wait a minute. It's going to be small I only. Yes, so I am assigning 2 integer variables I and j. Right? What about I and j? You can give the value range from, that means 16-bit values you can give. That's the mean for. In fact, what about the maximum count value you can give in the outer loop or inner loop? Yes. Here we have given 10, 20. Okay. What about the maximum count value we can give? As integer, it is going to be 16 bit. Yes, very good. I think 2 power 16 minus 1. 0 to 2 power 16 minus 1. Okay. And this we kindly check it. I think the value is, I think so. Okay. Here I am using 10 and 20. Okay. Can you suggest a suitable declaration variable I and j in this example? If I am going to always use, am I audible? I think I have disconnected and joined. Am I audible?
Audible, Ram,
Students,
sir.
am I audible? Okay, disconnect right there, join another cat. Okay. Fine. Okay, can you suggest a variable, suitable variable, I mean data types for the table? If I'm always going to use 10 and 20 in this function, can this mean that reduce the hardware resource available in the microcontroller? Yes. Yes, we can use character variable, okay, as the value 10 and 20. Wait a minute.
L132, Mega Prashant.
Mugun sir, am I audible now?
Yes, Ram, sir. Audible, Ram, sir.
Okay. Okay, I hope the presentation is visible to all of you and I am audible. Sorry students, due to some network issue, I am frequently getting disconnected. Okay, fine. So we can use, as you people said, we can use character variable. Okay, if I am always going to use the same value 10 and 20 in this particular loop, I can go with character data type variable. Okay, fine. Okay. It's very important as embedded application perform repeated operation, we can use super loop concept. Okay, so it is a new thing in embedded C. Okay, in the case of your C programming, you will have while of one. You said while of one. While of one means what? Always the condition is true. That means you have to write the repeated thing what you have done in the system like this. As Hamdan said, void loop, it is equivalent to this. Void setup means what are the lines we are writing outside the loop. That is going to be, I mean, before this particular while of one, we have to declare the variables and everything. That means initialization. That we call it as void setup. Okay. What we are writing within this particular loop, it is going to be executed repeatedly. Okay. Any embedded system you take is going to do the same operation again and again. That means what? A program is repeatedly getting executed in a continuous loop, infinite loop. Okay. So for your understanding, I have used the word infinite loop. Okay. So when you are writing the embedded C program, you have to be very careful in that. Okay. Whatever you are writing within this super loop is going to be considered as void loop. Okay. It is equivalent to void loop in your Arduino program. Okay. Fine. Then we will get into the devices now slowly so that we can able to have some program today. Fine. Okay, first we will go with the LED. Okay, we all know the operation of a LED. Okay, so LED is having two terminals, anode and the cathode. Obviously, anode is plus and the cathode we are representing with minus symbol. Okay, that means we have to connect positive voltage to anode and the negative voltage to the cathode or ground to the cathode. Okay, so that the LED will glow. Correct? Fine. So if I am doing like this, is it fine? I am connecting plus 5 volt to the anode and the ground to the cathode. Is it fine? Is it fine or not? What I have to change in this particular circuit if it is not fine? Yes? What we have to do? Yes, we have to introduce a resistor in series. Otherwise, it will damage your LED. Yes? So typically we will use 220 ohm resistor. Okay, so current limiting resistor. Fine. Coming to this thing, it is very, very important. Okay. Simple nama input output device kondu poi direct microcontroller la connect pannalama appdin paatha, it's not like that. You have to first check what about the current rating of your particular input device. That's very, very important. Input device or output device. Okay, fine. Coming to the output device, we are having two concepts, current sourcing and current sinking. It's very important concept, we must know. Okay, current sourcing abdina meaning enna paathomna, we have to provide the power from the port pin to the output device so that it will work. Yes, that means what? To the port pin, we are connecting the anode of the LED. It will be like this. Anode of the LED is connected to the port pin and cathode is connected to ground through a resistor. Okay. Now power to the LED comes from where? Whether external power supply we are using or the power from the microcontroller itself we are using. That means from the port pin we are using. Yes, port pin acts as a power source for the particular pin. Correct? That means if you write logic 1, 5 volt will be available here so that LED will glow. Correct? If you write logic 0, LED will get off. In the case of sourcing current from the port, okay, the active logic is 1. Active logic is 1. Okay, that means active 1 logic. Okay, active high logic. This particular configuration uses. Okay, you have to consider one thing. Suppose if the current rating of the particular device is greater than the current delivered by the port pin, whether this configuration shoots. In the particular configuration use panna mudiyuma. Suppose if I am going to interface some relay or some other device, okay, or buzzer, can I directly connect to the port pin? Yes or no? See, if the device is consuming more current than the current delivered by the port pin, what is going to happen? When you run the particular device, it draws more current from the port pin. If it exceeds the port current, the port will get damaged permanently. Okay, fine. So generally, when you are building an application using low power microcontrollers, sourcing current is not advisable. Okay, that means you have to use active low output devices. That means what? This concept. Here, externally we are providing an input voltage of 5 volt, okay, to the anode terminal through a resistor, and the cathode terminal is connected to port pin. What it means? This we call it as sinking current to the port. Okay, that based on the direction of current, we are saying sourcing current and sinking current. It's very, very important when you are connecting the output devices. Okay, when you are connecting any kind of device, you have to consider this. Whether the device is consuming more power than the current delivered by the port, then you can go for sinking. Okay, even though in the case of sinking, you have a certain current limit. Okay, source current is going to be a minimal thing. Sinking current can be somehow greater than the source current. Okay, you refer the data sheet of a microcontroller for what, for which you are going to build the hardware. Okay, fine. Source current, sink current, ரெண்டுமே கொடுத்திருப்பாங்க. Fine. So in our cases, we are going to follow the second configuration. That means active low configuration we are going to use. Okay, fine. So if the current is from the microcontroller to the device, direction of the current is from microcontroller to device, that we call it as sourcing. If the current is from the outside end to the microcontroller, that we call it as sinking. Okay. Okay, now we have to know how to interface LED with the microcontroller. So we are considering 8089S52 microcontroller. In that we are having 4 ports. Among that, we are considering one of the port pin from port 2. Fine. We are having 4 ports. We are considering port 2. From the port 2, we are considering only one pin, that is P2.0. Okay. So as I told, we are going to follow active low configuration. The power which must be given from the power supply. It must not be given from the microcontroller port pin. Okay. Then the ground, the cathode terminal is going to be connected to the port pin. That means what? When the LED will get glow, yes, writing logic 0 means ground, writing 1 logic means 5 volt. When the LED will get glow? Any idea? In the particular circuit connection, logic 1 port pin P2.0. LED on aguma off aguma. See, this and all you have studied earlier. You are just refreshing here. Yes, writing logic 0 will make the LED to glow. Writing logic 1 will make the LED to turn off. Correct? Students, am I audible? I was disconnected from the classroom 1. So I have joined again. Am I audible?
Excellent, sir. Audible, sir.
Okay, fine. So interfacing of LED with microcontroller we are discussing. So when you write logic 1 to this particular hardware configuration, LED will get turned off. If you write logic 0 means LED will get turned on. Okay, fine. So we are having 4 ports, port 0, port 1, port 2 and port 3. Okay. So each port is having 8 IO pins used to connect the input or output devices. So here in the case of embedded C programming, okay, we may not use the variable with dot symbol. Okay. See, ஒரு particular variable நான் assign பண்ணிருக்கேன் அப்படினா அதுல dot symbol நமக்கு இருக்க கூடாது. That means a variable should not contain a dot symbol in between the naming. Fine. So for that, we are using the notation underscore symbol instead of dot for addressing the port pins. Is it clear to everyone? See, actually 80, 87 அப்படின்றதெல்லாம் இதோட அட்ரஸ். இந்த அட்ரஸை நம்ம எதுக்கு மேப் பண்ணியிருக்கோம்? P0 அப்படின்ற particular naming க்கு map பண்ணியிருக்கோம். That means what? In your program, if you use P0, indirectly it is pointing to the address 80 that represent the port register. Okay. If I use P0 underscore 0 means it is indirectly pointing the bit address 80H, which is the least bit significant bit of the port register. Fine. Okay. Next. So similarly for port 1, we are having the same notation. Port 2, port 3. So these are the notations we have to follow. Okay. So after this, we will get into the programming concept. Okay. Mukund sir.
Sir.
Mukund sir, am I audible?
Yes, sir. Audible, sir.
Okay. Okay. இங்க பவர் வந்து இதாயிடுச்சு முகுந்த் சார் எனக்கு.
Okay, sir.
லேப்டாப்ல 20% சார்ஜ் இருக்கு. நான் சார்ஜ் போட்டு யூஸ் பண்றேன், பட் ஸ்டில் 20% சார்ஜ் தான் இருக்கு.
ஓகே.
சப்போஸ் நமக்கு ஆஃப் ஆயிடுச்சுன்னா கொஞ்சம் கண்டினியூ பண்ணுங்க, பவர் வந்தோடனே நான் ஜாயின் பண்ணிடுறேன்.
எஸ் சார்.
ஓகே முகுந்த், thank you. Okay, now we can write the embedded C program. We have gone through enough concepts to write the embedded C program now. Okay, as you peoples are well enough in C programming and a concept of a microcontroller, that means 8051 microcontroller, we can able to write the embedded C program now onwards. Okay, fine. The very first line, here the program is intended to turn on the LED connected at port pin P2.0. Fine. The very first line, what we have to do is we have to include the header file of the particular microcontroller for which we are writing the program. எந்த மைக்ரோகண்ட்ரோலருக்கு நம்ம ப்ரோக்ராம் எழுதுறோமோ அந்த மைக்ரோகண்ட்ரோலரோட header file, library file we have to include. Okay, why we have to include this particular header file? In that header file only, all the register address and SFR address, everything will be mapped to the naming. Say for example, P0 use panna meaning enna? Port 0. Appa 80 and the address map automatically. Fine. So that address mapping can be done in the header file itself. Okay. Wait for a moment. I will share the header file screen, sample header file screen now. Wait a moment. Wait a moment. Okay, now I will open the sample header file. So we have included 8089s52.h, correct? You can see what are the things available in that particular header file. Can you people see the screen? Is it clear? Here you can see $_SFR at 0x80. That means the hexadecimal address 80H is assigned to the letter P0. Suppose inga na P0 ku badala port 0 pota mean header file suppose P0 badala port 0 na type panna meaning enna? When you are writing the embedded C code, what you have to do? Yes, can you respond? Yes, can you people respond? Yes, entire port 0 only. P0 use பண்ணிருக்கோம் நம்ம இங்க. That means also entire port only. Anthony Surya. If the naming I have changed in the header file as port 0, உங்க program எல்லா இடத்துலயும் நீங்க என்ன பண்ணி ஆகணும்? Port 0 தான் யூஸ் பண்ணணும் to address the port 0. For example, port 0 னா ஒரு value எழுதணும்னா P0 equal to that value. Directly you can write. Okay. As for the current situation, ATH அப்படின்றது எதுக்கு மேப் பண்ணிருக்கோம்? P0 ன்னு மேப் பண்ணிருக்கோம். Correct? That means using this embedded C concept, you can access the register level. Register level access வந்து நமக்கு embedded C ல பண்ண முடியும். ஆனா நார்மல் C ல நமக்கு அது இருக்காது. Correct? Are you able to understand what I am saying? For which hardware you are writing, the register resources எல்லாம் use பண்ண முடியும் embedded C ல. That's the meaning. That's the advantage of having the header files. Okay. Wait a minute. Yes. Okay. If I got disconnected, kindly intimate me. Fine. So hash include AT18S52.h. If I included this particular header file, then all the register definitions will be mentioned. Otherwise, what I have to do? And the header file இருக்கிற எல்லா ஃபங்க்ஷனும் நான் இங்க எழுதணும். Fine. Without using header file also, we can write the program. Okay. But you have to assign the hardware resources. What are all you are using to some naming. That naming refers to the particular resource. Okay. Fine. So void main. So what you are writing within this particular function, it is going to be the main program. In the main program, first you have to initialize. As Hamdan told, void setup அப்படின்னு சொன்னார் இல்லைங்களா? ஸோ அதே மாதிரி இங்கே வந்து நம்ம ஃபர்ஸ்ட் எழுதக்கூடிய லைன்ஸ். ஓகே, ஸோ அதை வந்து நம்ம என்ன சொல்றோம் அப்படின்னு பார்த்தீங்கன்னா இனிஷியலைசேஷன், வாய்ட் செட்டப். இனிஷியலாக நம்ம என்ன பண்றோம்? எல்இடி வந்து டேர்ன் ஆன் பண்றோம். ஃபைன். இங்கே நமக்கு இனிஷியல் செட்டப் எதுவும் கிடையாது. கரெக்டா? The intention is to turn on the LED. Correct? So we are turning on the LED. Whether we have to do any other work, Yes? No. So what we can do? We cannot simply left it. Void main போட்டு நான் இதை எழுதிட்டேன். ஃபர்ஸ்ட் லைன் எழுதிட்டேன். LED ஆன் பண்றதுக்கு இந்த கோட் எழுதியாச்சு. கரெக்ட்? If you compile this program and run in the simulator, P2.0 ல கனெக்ட் பண்ணிருக்க LED ஆட்டோமேட்டிக்கா நமக்கு என்ன ஆகும்? டர்ன் ஆன் ஆயிடும். Fine? So we don't need to do any other operation after this. So what we have to do? இதோட ப்ரோக்ராம் முடிஞ்சது இல்லையா? யூசுவலா உங்களோட அசம்பிளி லாங்குவேஜ் ப்ரோக்ராம் எழுதுறப்ப at the end of the program 8051 ல நீங்க என்ன யூஸ் பண்ணீங்க? ஞாபகம் இருக்கா? You should not just left as it is. உங்க ப்ரோக்ராமோட எண்ட்ல கண்டிப்பா நீங்க ஒரு லைன் எழுதிருப்பீங்க, ஒரு இன்ஸ்ட்ரக்ஷன் எழுதிருப்பீங்க. என்னது ஞாபகம் இருக்கா? Yes, very good Dixon, very good, super. What it means? That is equivalent to infinite loop. Am I right? Am I right or not? Yes, that is equivalent to, yes, we have to use a dummy while loop. So while of 1, nothing we are going to do. Yes, is it clear now? So in the particular program, நம்ம எழுதிட்டு நம்ம என்ன பண்ணலாம்? We can able to see the result in MC8051 IDE. Please remember one thing, you need SDCC software and MC8051 IDE to write embedded C program. Because MC8051 IDE support only assembly language by default. If you people install SDCC, then only you can write embedded C program in the MC8051 IDE software. Okay. Now I will open the MC8051 IDE software and we can start writing the program. Okay, shall I start? Yes. இன்னைக்கு பார்க்கலாம். ஓகே, ஸோ இந்த ப்ரோக்ராம் இன்னைக்கு பார்த்துட்டு இதுல வந்து எல்இடி ஆஃப் பண்றது எப்படி, தட் அண்ட் ஆல் வி கேன் சி. ஓகே, கேன் சி டுடே. நமக்கு என்ன தெரியணும் அப்படின்னா ஹவு டு ப்ரோக்ராம் தி மைக்ரோ கண்ட்ரோலர் யூசிங் எம்பெடட் சி. ஸோ நமக்கு தெரிஞ்ச நாலேஜ் வச்சு நம்ம என்ன பண்றோம்? We are writing some embedded C program to program the microcontroller. Okay, is this program is easy to understand by all of you people? இல்ல doubts இருக்கா இந்த ப்ரோக்ராம்ல? Is it clear? Is it clear to everyone? Yes, clear. Okay, fine, fine. Okay, fine. So now I can go with the software. Okay, so how to create a project and write an embedded C code in MCA81 IDE we will discuss now. Okay, so இங்க நான் வந்து PPT ல வந்து என்ன பண்ணிருக்கேன்னா step by step இது போட்டிருக்கேன். இந்த screenshot எடுத்து வச்சுக்கோங்க. Later point of time நீங்க வந்து program பண்றப்ப இது யூஸ் ஆகும். Okay, so in this way only we have to do the programming. Okay, என்னோட இது நான் ஓபன் பண்ணிட்டேன் அப்படின்னா நீங்க வந்து பீரியாடிக்கா ஸ்கிரீன்ஷாட் எடுக்கிறதுக்கு பதிலா இது ஸ்கிரீன்ஷாட் எடுத்தா ஸ்டெப் பை ஸ்டெப் ப்ரொசீஜர் உங்களுக்கு நல்லா புரியும். ஓகே, ஸோ ஃபர்ஸ்ட் ஸ்டெப் வாட் யூ ஹேவ் டு டு, we have to click project. Fine, and take a screenshot. ஃபுல் ஸ்கிரீன் பண்ணட்டுங்களாப்பா? இது ஃபுல் ஸ்கிரீன் பண்ணட்டுங்களா? or else it is enough? Is it clearly visible? Yes, okay, fine. First what we have to do, click on project. Next what we have to do, click on new project. To create a new project we have to click on new. Okay, once you click on new, a pop-up will appear like this. Okay, here you have to type the name of the project name la enna pananum, you have to type the project name. Okay, LED blinking நம்ம இது பண்ணிப்போம். Say for example LED ன்னு கூட வச்சுக்கலாம். Next project directory. Fine, choose destination folder அப்படின்னு சொல்லி ஒரு ஐகான் இருக்கு. ஸோ அதை கிளிக் பண்ணோம்னா எகைன் ஒரு பாப்அப் வரும். ஸோ அதில் நம்ம ஃபர்ஸ்ட் என்ன பண்ண போறோம், நியூ ஃபோல்டர் கிரியேட் பண்ண போறோம். நல்லா நோட் பண்ணிக்கோங்க, எந்த லொகேஷன்ல இருக்குன்றது ஃபர்ஸ்ட் முக்கியம். ஃபைன், முகுந்த் சார்.
ராம் சார் சொல்லுங்க. ராம் சார்.
முகுந்த் சார்.
ராம் சார் சொல்லுங்க.
பேட்டரி லோ ஆயிடுச்சு, 10% வந்துருச்சு.
ஓகே, நான்
10% வந்துருச்சு பேட்டரி. ஓகே சார், நான் இத கண்டினியூ பண்றேன். கட்டாயமா நீங்க கண்டினியூ பண்ணுங்க.
ஓகே ராம் சார். ஓகே
ஓகே ஓகே. ஸோ கிளிக் ஹியர் டு சூஸ் த டிரைவ். ஸோ எந்த டிரைவ் போகணுன்றதை சூஸ் பண்ணிக்கலாம் இங்கே. ஸோ நம்ம டி டிரைவ் போயிட்டு அதில் என்ன பண்ணுறோம், நியூ ஃபோல்டர் கிரியேட் பண்ணியிருக்கோம். ஆர் எல்ஸ் வாட் யூ கேன் டூ, டாக்குமெண்ட்ஸ் அண்ட் செட்டிங்ஸ் கிளிக் பண்ணுங்க. யூ கோ டு டாக்குமெண்ட். தட் மீன்ஸ் உங்களோட ஃபைல் எங்க இருக்குன்றது உங்களுக்கு தெரியணும், அதுக்காக தான். ஃபைன், ஒன்ஸ் யூ ஹவ் டன் டைப் தி folder name and select the folder name. Okay, then select 8089S52. Okay, select 8089S52, select the microcontroller. So அதுக்கப்புறம் நம்ம என்ன பண்ண போறோம் அப்படின்னு பாத்தீங்கன்னா click on OK. Here we are not going to use external memory, ROM RAM யூஸ் பண்ண போறது கிடையாது. So we are using only the internal ROM and RAM memory. So click on OK. So you can have a window like this. Now click on File, save as. It's very important. It's very important. Kindly note down. It's very important. Save as இங்க நீங்க என்ன பண்ணணும், ஃபைல் டைப்ல போயிட்டு C source .c அப்படின்னு இருக்கு, அதை செலக்ட் பண்ணிக்கிட்டு then you have to write the source code file name end with .small letter c. That's very important. Type the project file name with the .c extension. Okay, இந்த .c extension நீங்க போட்டாதான் இது வந்து C ஃபைலா கன்சிடர் பண்ணும் உங்களோட MCA81 ID. You have to mention, even though you are selecting the file type, you have to mention .c at the end of the file name. Don't use any space or dot in between the file name. Okay, underscore யூஸ் பண்ணிக்கலாம் காமனா. Okay, dot o இல்ல வந்து நம்பரிங் யூஸ் பண்ணாதீங்க. Your file name should must not start with numbering. Say for example 1 LED அப்படின்னு எழுதக்கூடாது. LED underscore போடலாம். Fine. Okay, next. Once you have done, it will ask you to save the project file. Yes. Okay, now here you can see C/H. That means using this particular software you can write both C file, C source code as well as the header file. Okay, so நம்ம ரெண்டுமே எழுதிக்கலாம். இங்க நம்ம எழுத போறது ஒரு embedded C program. So as we discussed earlier, as include 8089S52.h void main, and the program அப்படியே போட்டாச்சு. Fine. So after this what we have to do, the program வந்து compile பண்ணனும், கரெக்ட்டுங்களா? So we have to click on simulate, then click on debug this file only. Okay, then again once you've done that, it will ask you whether you want to add this data to the simulator Yes. Okay, now see the message. You have to see a successful message. So these are the steps you have to follow to build a project, to write a program and to compile. Once you have compiled the program, you can able to run it in the simulator. Okay, so this particular MC8051 ID has inbuilt simulator. Okay, so அது நம்ம என்ன பண்ண போறோம் அப்படினு பாத்தீங்கன்னா, you have to go to virtual hardware tool, select. So அதுல வந்து நம்ம LED panel select பண்றோம், select. After choosing the LED panel, click to choose the port and pin number. P2 we are selecting, then 0th pin we are selecting. So P2.0 we have selected. Then click on the settings icon, enable Windows always on top. இப்போ என்ன ஆகும்னா நீங்க ப்ரோக்ராமும் இதுவும் ஸ்விட்ச் பண்ணி பார்க்கறப்ப உங்களோட ஸ்கிரீனுக்கு பின்னாடி போகாம இருக்கும் இந்த விர்ச்சுவல் ஹார்ட்வேர். ஓகே ஃபைன். நவ டர்ன் ஆன் பண்றப்ப இட் வில் ஷோ யூ a warning. என்ன வார்னிங் அப்படின்னு பாத்தீங்கன்னா, உங்களோட சிமுலேட்டர் பெர்ஃபார்மன்ஸ் வந்து கொஞ்சம் கம்மியாகும்னு சொல்லுங்க. Because when you are using virtual hardware, obviously the performance of the software will be little degraded. Okay, it doesn't mean real hardware la degrade ஆகும் கிடையாது. It's regarding the simulator. Okay, so click on OK. Now debug this file only. Already பண்ணிரோம். Fine. Now we have to click on run. உடனே நமக்கு என்ன ஆகும்? No LED is glowing. So these are the things will happen. If you do the particular steps in the MC8051 ID software, you can have the LED get low. That's all. So LED on பண்றதுக்கு the simple program இன்னைக்கு நம்ம பார்த்திருக்கோம். Fine. Obviously we will go with the simulator demonstration. Okay, இப்போ நம்ம சொன்னது அப்படியே வந்து demonstrate பண்ணிக்கலாம். இந்த ஸ்லைட்ஸ் எதுக்கு நம்ம போறோம் அப்படினு பாத்தீங்கன்னா, for your understanding purpose, we will create a Google Classroom for this value-added course. Okay, there we will share this as a documentation. So என்னென்ன ஸ்டெப்ஸ் ஃபாலோ பண்ணனும்ன்றத ஒரு PDF ஃபைலா கன்வர்ட் பண்ணி நான் டாக்குமெண்டேஷன்ல போடுறேன். Fine. Then we will assign some tasks and quizzes periodically, I mean daily, in that particular classroom. So இன்னைக்கு evening possibly you will get the invitation link. Kindly accept and join by today itself. Okay, so daily நம்ம வந்து ஒரு quiz task, if we assign any task we will post the task, otherwise we will post simple quizzes. Okay, what are the contents we have discussed today? So other regarding quiz நம்ம post பண்ணுவோம். So kindly attend the quiz. Okay, if you are doing this valued course properly, you will be earning a certificate probably. Okay, fine. So in the value-added course பொறுத்த வரைக்கும் definitely you can have some confident level to program the microcontroller using embedded C. Okay, so இது நமக்கு தெரிஞ்சதுன்னா later we can go with PIC microcontroller or some other microcontroller, ARM based microcontroller. Okay, ARM board based microcontrollers we are having. Okay, so such microcontrollers you can able to program. Okay, I want to
Okay, students, we will proceed with the simulation portion. Okay, let me open the tool and present for you. Wait for a few minutes. Okay, I'll present my whole system so that whatever the files I'm opening, you can check those files. Okay, so is my screen visible? Yes. Okay, so listen students, we are going to work with MCU8051 IDE. This is the tool we are going to use, but to program embedded C program in this particular tool MCU8051 IDE, you need to install SDCC. Okay, SDCC, a small device class compiler you need to install. You can download that SDCC as it is an open source tool. You can download it from Google itself. Okay, I hope you people have this MCU8051 IDE with you. Okay, the very first step is you have to install SDCC compiler first. Okay, so you can check my download folder. I have that SDCC software being downloaded and installed it.
Sir, continue பண்ணிக்கிறீங்களா?
Yes, Ram sir, continue பண்ணிக்கிறேன்.
Okay, Moon sir, thank you.
So after installing SDCC file, you can go to install MCU8051 IDE. Okay, so that SDCC will be configured to this MCU8051 IDE. Okay, once these two softwares being installed, now you can open this MCU8051 IDE. Okay, as presented in the slides, we will move step by step. Okay, so now our tool is ready to program. Okay, so you can check this configure compiler C language. There they have mentioned for C language SDCC is the compiler, right? So once you install SDCC first, and then you need to install this MCU8051 IDE. Okay, so as the presentation says, first we need to create a new project, right? We have to create a new project. Okay, you can create you can give any name you want. Okay, I'm going to give us value added course VAC, and the project directory I can choose any directory. Okay, it is better to choose with documents always. Okay, so I have select the documents. Okay, then I have to check whether the processor type is selected as 8089S52. Okay, once this is done, you can click OK. Okay, now you can find a new project is being created. Okay, and after that project, we need to save the file initially. Why? Because you can see the tool, it is showing the file name is untitled. Okay, it is a default opened file, right? It is being untitled as the name, it is untitled. You can clearly see here it is untitled ASM. You people know ASM means it is assembly file, correct? ASM is assembly. Okay, now we are going to work with C programs, right? Embedded C program. Okay, so for that we need to you can go with right click here, or otherwise go to file and save as. Both can be happening. Okay, okay, save as, click save as. Locate where we create our VAC file. So it comes under documents. Here documents, you can find VAC. Yes, it is VAC. It is available here. Okay, right. So in the same folder, I can select the files filter as .c file initially. Then I can type LED on. It is my wish, no? Whatever the name I wish, I can give without any space. And your file name should start with a letter. Okay, not with a number. Okay, and I have to give a small c, right? LED on .c. Okay, click OK. Now, do you want to add this file to the project? Yes, of course. Now you can see your file name is changed to LED_on.c, and now you can check here too at the bottom. You can find LED_on.c c/h. Previously, what will be the file type here we have mentioned? Can you people just type in the chat? Before altering the title, file title, what will be the file type it is available there? Yes, it is ASM. Now you can see it is C/H. That means the file can be of a C file or a header file. Okay, a .c extension or a header file extension you can go with. Okay, so now our screen is ready to type the program. Okay, now as we discussed earlier, to turn on an LED, we had the program, right? Before that, first the very first step is to include header file, correct? So how the header file name is going to be available? Once you install your SDCC, okay, go to your C drive, okay, program files, Under program files, you can find SDCC. Can you people observe on the screen SDCC? If you install your SDCC, it is going to be reflected here. Okay, open that SDCC. Okay, you can note down these steps. Okay, this is must before start of your programming. Okay, and you can go to include. In include, you can find many header files and with some folders, right? So we are working with 8089S52, right? It is a 8051 microcontroller family. So you need to check with MCS51. Okay, you can find a folder name called MCS51. Double click it. You can find many header files. Okay, all these header files are related to 8051 family of microcontrollers. Okay, so in that you can find, once you installed, okay, you can find a header name called AT89S8252. okay, initially the file will be available with that name only. Okay, I will type that in the chat. Okay, after installing SDCC, your header file is going to be available like this only, AT89S8252.h. okay, so it is going to be available like this only. Okay, the same thing I will post in the one more classroom too. Okay, now can you people give me in our program what is the header file we have used? Already you people noted down the program, right? It is being explained in the slide itself. Okay, what will be the header file we have used? Can you people type it in the chat? Yes, hash include AT89S52.h. Okay, so if suppose I'm not having the same file name here in this folder, what will happen? It will show you error, correct? The header file should be named as it is. Okay, so for our purpose, what we are going to do is, after installing SDCC, okay, after installing SDCC, you can find a file name called AT89S8252.h. that should be renamed as AT89S52.h like this. Okay, as we used in our program. Okay, the header file capital AT89S52.h, you have to replace the older file name with the new one. Okay, so what I have typed in the chat box, that is going to be available with the software SDCC once you install. Okay, after that you have to rename it. You have to rename it as AT89S52.h. You have to do this before you start off your program. Otherwise, what will happen? It will show you error. Your program will show you error. Okay, clear about this point? Clear about this point? Why? Because you people are going to work in this tool. Okay, at that time, you should not check with, you should not get with an error for the header file. Okay, that is why I'm explaining clearly here. Is that clear? Yes, is that clear? Yes, okay. Now, so you can check in this particular folder, as I have already modified it, you can find the same file name, AT89S52.h. Okay, now we can start off our program. Okay, the very first line says it is hash include AT, how you gave your header file, the same format you have to provide here too, AT89S52.h. Okay, right. Once I include my header file, the very next step is going to be void main. Okay, then open braces. In that, I'm going to turn on an LED, right? So the LED is going to be connected in port 2 of pin 0, right? So P2 underscore 0 is equal to 0. Okay, right. So after that, what I should do? After that, what I should do? I have turned on the LED. Here we are providing logic 0 to turn on the LED because of the LED logic is being connected in that way, right? It is going to be syncing, right? Syncing connection. Okay. So what else I need to do after making my LED turn on? The next step is my program is over, right? The purpose of the program is to turn on the LED. So I did that. Okay. Is there any extra lines I need to put here, or otherwise I can close the program? Yes, with this line I can close my program. Shall we start simulator? Yeah, we have to provide the super loop or the infinite loop we need to provide, right? So it is going to be while of 1 simple braces, right? Okay. So now my program is over, right? Okay. Right. So I can, after typing, I can save it once. And the next step is simulate, debug this file. Okay. Before debugging, what we can do is we are going to work with hardware simulation, right? So we can go to virtual hardware. Okay. We are working here for the LED, right? So we have to select virtual hardware LED panel. Okay. LED panel. So this is the LED panel. Initially, you can turn it on. Okay. You can turn it on and then go to the settings. You can press Windows always on top. Okay, so if you give that, then this particular window will not be minimized by itself. Okay, when you minimize it, it will be minimizing, or otherwise it is going to be available in the front screen itself. Okay, then only it will be easy for us to check the output. Okay, now our port pin we have used is port 2, right? So under port, I need to select port 2. Which pin I am using? 0th pin of port 2, right? So in the bit side now, I have to select bit 0. Okay, this will be the LED. You can change this LED colors, that is by clicking the setting button. Okay, you can go with the color. You can find all these colors: red, orange, yellow, green, blue, purple, and you can select whatever color you wish. Okay, right. Once this is done, okay, now you can go to simulator. Under simulator, you can find a debug this file only. Debug this file only. Okay, so you can click on it. Is going to give you one warning: simulator data file not found. Do you want to create it? Yes, of course, create it. If you press yes, then it is going to be, you can find the messages starting compiler. So it starts compiling it. Okay, yet to compile. Right, see here, once if it is compiled successfully, you can get the simulator screen directly. Also, you can go to the messages. You can check the message, successful message, compilation successful. If you have any error, okay, that error is going to be reflected here. Okay, for example, we can shut down the simulation. Okay, once I'll do purposefully, I'm creating some error in the header file. Okay, so the previous file name, no, 8089s8252, right? I have provided the same file name 8252. Okay, now I am simulating it. Debug this file. Yes, of course, you have to simulate. So you will see what it is going to give me. Okay, see here, compilation failed. See messages for details. Okay, so in the messages side, you can find warning 190 ISOC forbids an empty source file. Empty source file in the sense the header file is not available. Okay, in the specific folder, header file is not available. So what we need to provide is, we need to provide the exact name as it is available in the folder. Okay, MCS51 folder under SDCC file. Okay, so now you can re-edit the header file as 8089s52.h. I've debugged this file. Yes. Oh, unable to read simulator file. Possibly you have disabled generation of simulator file. in computer configuration dialog. Just a minute. Okay, I think if we edit multiple times, it may give an error like this, unable to read simulator file possibly. Okay, at that time, what you need to do is you need to close the tool and you have to reopen it, and it will work fine. Okay, we'll do that once. Just a minute. As we have stored our program.
Sir.
Ramsa solunga.
அதுல ஆக்சுவலா அந்த ஃபோல்டர் இருக்கு இல்லைங்களா, ஃபோல்டர் நம்ம கிரியேட் பண்ணிட்டு போடலாம்னு நினைக்கிறேன். டாக்குமெண்ட்ஸ்ல அப்படியே ஃபுல்லா இதா இருக்குன்னு நினைக்கிறேன் ஃபைல்ஸ்.
ஓகே ஓகே ராம் சார், ஃபோல்டர் கிரியேட் பண்ணி கனெக்ட் பண்ணிக்கலாங்களா? ஓகே, so you can create we have created only
இல்லனா அதுல உள்ள அந்த .co ப்ராஜெக்ட் ஃபைலும் தவிர மத்த எல்லாத்தையும் டெலீட் பண்ணிட்டு பாருங்க.
ஓகே ஓகே ராம் சார். ஓகே,
அந்த லொகேஷன்ல உள்ள .c ஃபைலும் ப்ராஜெக்ட் ஃபைல் தவிர மத்த எல்லாம் டெலீட் பண்ணிட்டு ட்ரை பண்ணி பாருங்க.
See, once you simulate it, you can find all these files, supporting files. Okay, so you don't want to mess up with your folder. That is why we have already told you people to create a folder, but unfortunately I did not do that. Okay, so what I'm going to do is I'm going to delete the other files except the .c file. Okay, I'll delete those files. Okay, now we will try it. This file. Yeah, simulator data file not found. Do you want to create it? Yes, of course, yes. Okay, now we have changed the file, header file name. We will check the messages. Yeah, it shows compilation successful. Now you people understood the edit of the file name, the importance of editing the file name. Okay, right. So now we need to open the virtual hardware. Okay, you can do this at any point of time. That's not a problem. Before simulation, you need to do this. Okay, so we have to select port 2 and bit 0. Okay, we can give Windows always on top. Right now we can run it. You can either give run or animate. If you do animate, what you can find is this yellow line. No, it is going to be movable in the screen. Okay, so you can give both animate and run. It's better to give animate.
எவ்வளவு கொடுத்து விடாதா? சரிடா, சரி.
Sabrish,
இங்க இதா எனக்கு தரலையா?
239 Sabrish.
150 ரூபா கொடுக்கவா?
ராம் சார் அவரை மியூட் பண்ணி விடுங்க ராம் சார். Okay, see, now you can find. All right, our LED is being glowing. Right, I'll do it once. Sabrish disturbed the classes, it seems. Okay, right. So debug this file, simulator. Now you can find this LED is being off condition, right? Once I have pressed run, it is being yes. Now see, you can find the LED is being glowing. This is what our program, right? To turn on LED, we have done the program and we did the output. We get the output, right? That's all about today's class. Okay, is there any doubt with this particular thing? You can find the files link in the chat box. Okay, Ram sir already posted it for downloading SDCC as well as MCU8051 IDE. You can download easily and you can install it.
சார் இன்னொரு கிளாஸ் ரூம்ல போஸ்ட் பண்ணிடுறீங்களா?
நான் பண்ணிடுறேன் சார். எஸ் So far whatever we have discussed, everything is clear. Am I audible to all?
கேக்குது மோகன் சார்.
Yes. Okay. Right. So no doubts, right? Okay. So Ram sir, task வந்து class போஸ்ட் பண்ணிக்கலாமா? பண்ணிடலாம் Ram sir.
ஆமாமா. இப்போ இன்னைக்கு நம்ம எதுவும் பெருசா சொல்ல எல்இடி ஆன் தான சொல்லியிருக்கோம். நெக்ஸ்ட் கிளாஸ்ல டாஸ்க் கொடுத்துக்கலாம் நம்ம.
ஓகே Ram sir, okay. Right, okay.
இந்த கிளாஸ் ரூம்ல போஸ்ட் பண்ணிட்டீங்களா அந்த லிங்க்?
போஸ்ட் பண்ணிட்டேன்.
Okay, okay மோகன் சார்.
Okay students, you can note down the link to download the files. Okay, download பண்ணிக்கோங்க, install பண்ணுங்க, உங்களோட systems ல install பண்ணுங்க, doubts இருந்ததுன்னா clarify பண்ணிக்கோங்க and try to explore it. Okay.